A car is travelling on a bend with a radius 10 metres at the speed of 80 kilometres per hour. A police car is moving along with the same angular speed as the original car, but the circle is of radius 12 metres. At what speed is the police car travelling? So we just look at this. Okay, here we have a GeoGebra app. So here we have the path of the car, and here we have the path of the police car. The red bit will represent the distance travelled. So notice the police car is obviously going to travel at a more distance than the car. So therefore, its speed here, going around the actual speed, has to be more than this one. However, we notice if we look at this, the rate of change of the angle is the same. This is what's happening here as we're going around a bend. All right. So, converting the 80 kilometers per hour into meters per second, yes, because we have to have the correct units. So 80 kilometers per hour is 80 times 1,000, because 1 kilometer is 1,000 meters, divided by 60 minutes, and 60 times 60 seconds. Some books this would be written straight away as 3,600. That gives me 200/9 meters per second. Using v is equal to r omega, so omega, the angular speed, will be equal to 200/9 divided by 10, the radius of that the car is actually travelling around, which gives me 20/9 radians per second. Now for the police car, v is equal to r omega, so that's going to give me 12. That's travelling at a radius of 12 times 20/9, because they both have the same angular speed. And that's going to give me 80/3 meters per second. So what we've got to do now is convert that back to kilometers by hour by doing the inverse. So this comes to the top and this goes to the bottom. So converting into kilometers per hour, we're going to have 80 times 60 minutes times 60 seconds divided by 3 times 1,000. 1 kilometer is 1,000 meters. So that's going to be me 96 kilometers per hour. And we'll just go have one back and have a look at that applet again. So what we've got here is two cars travelling around a bend. The police car would have to travel its speed, because you can see its distance here is more than this distance here. It would be more, so if the speed would have to be more than this speed, but the rate of change of the angle here, the angular speed, will be the same. This is what's actually happening as it goes around a bend.